Hello YouTube, this is Liam from sixthformonline.co.uk and I'm here to further my previous video. In my previous video I showed you how to download Microsoft Mathematics from dreamspark.com and I briefly shown you some of what the software could do. Today I want to go deeper into that and I want to show you really what this software can do. So I dug out my Core 1 maths book by edXL, Modular Mathematics, and I went through the topics and I found topics that you could use this software with. Some of the things it did really well was algebra, for example, indices, expanding brackets, further indices, factorizing, quadratics, cubics, polynomials, intercepts, graphing, search, differentiation, integration, and so much more. So we'll start with some examples. We'll jump straight back in. Here was one of the questions in an algebra topic. It was a cubed in brackets all squared multiplied by, and you'll notice that Microsoft Mathematics used the mathematical notation of the period instead of a times sign, so it doesn't get confused with algebra, times by 2a squared. Now the question asked me to simplify this equation. If I was going to simplify it on paper, I'd do indices rules. 3 times 2 is a to the 6. A to the 6 times a to the 2. Indices rules, you plus them together, that would be a to the 8. The answer is going to be 2a to the 8. But instead of having to do all that, I can press enter and it gives me the answer for me. There you go. Simplifies it down to 2a to the 8. This is great. That was quite a simple question for it. It can also do a lot more complex equations. Here's one with brackets. 4 lots of a plus a squared b minus 3 lots of 2a plus a squared b. Now if I was to do this equation in my head, I'd have to expand out the brackets, both sets, group all the like terms, and then simplify. But with the program again, I click the button and it gives me it in a simple form. But on this equation, if you've noticed, this little bit here, it says I can actually factor it. And what that will do is it will take it out in terms of a, because I don't know if you can see, but there's 2 lots of a here. So I'll factorise it, and there we go, it gives me it in terms of a. Other things it's good for is further indices. So for example, 27 to the power of a third. I don't know if you know, but that means the cube root of 27. And if we press enter, it gives us 27 to the third, and then the answer simplified is 3, because the cube root of 27 is 3. It does both positive and negative, so we could do 27 to the minus a third to the power of a minus a third, and this will obviously give us 1 over 3, or 0.3 recurring as a decimal. And there we go, it simplified it and gave us a decimal output, which is great. Other things it's good for is factorising, quadratics, cubics and polynomials, and also intercepting lines, which I'll discuss later. But let's take an example. Let's think of something that will factorise. X squared plus 3x plus 2 should factorise. So now if we press factorise this expression, it factorises it, and there we go, it gives us the 2 factors, which is x plus 1 and x plus 2. Now if you're a mathematician, you'll know that these two here are not the solutions. X is not equal to 1 and x is not equal to 2. It's in fact x is equal to -1 and x is equal to -2 for this equation. Now to get it to solve it and give you solutions, you've got to set it to 0. So to do this, we'll write it out again. X squared plus 3x plus 2, and this time we set it equal to 0. So we tell it that we can find solutions. And there we go, solution 1 is x equals minus 2, solution 2 is x equals minus 1. The great thing about this though is it doesn't just give us the answer, it shows us how it's solved the equation using, in this case, the quadratic formula. So if we expand this, it gives us a step-by-step guide of how exactly it's got the answer. So it says this equation is in the standard form of ax squared plus bx plus c equals 0, which is in the standard form for quadratic equation. It also tells you for this set equation substitute the number 1 for a, 3 for b and 2 for c, so you can see exactly where each number's going and what letter place in, and it does it in very simple to understand steps, so you can clearly see where it's gone from the previous. So for example, it says square the 3 and then it moves on to the next step. Multiply minus 4 by 2, add 9 to 8 and so on. As you get to the bottom of one, it also shows you that you've got to do it for the plus and minus of the equation, so you have to do it twice and then it walks you through the second solution. If however you haven't been taught the quadratic equation way, or you don't like doing it by that way, it shows you how to solve it from completing the square. So if we expand this one, it'll show you again step by step, nice and easy, how to solve the equation by completing the square, which is very good. Other things that it can do really well is it doesn't just factorise, you can also use it to expand. So if we put x plus 2, x minus 1 in the brackets and we press enter, we can actually use this here to expand the expression. A quick thing to note, on the output it shows you the congregate or the opposite. That's just something quickly to say. But if we expand this expression, you get x squared plus x minus 2. What it's basically done is multiplied out the brackets. So we've showed you factorising, expanding, quadratics. It can also do cubics and polynomials. I'll give you a quick example. X cubed plus x squared plus x plus 1, and if we factor this, it gives us x plus 1 lots of x squared plus 1. It can also do polynomials, which is expressions greater than cubics. So for example, x to the 4 plus x squared plus x. Now if we factorise that, it will give us the factor of that. It's also good for intercepts. So if you want to find the intercepts of two functions, for example a quadratic and a linear equation, intercepts are where the two lines meet. So here's an example. We'll say x squared was one equation, x squared plus x we'll say, and we want to find out where it meets with the linear equation 2x plus 2. So to do this, we set the y coordinates equal to each other. So we do 2x plus 2. So it'd be y equals x squared plus x, and y equals 2x plus 2. So we set these two equal to each other and press enter, and it gives us the solutions. Now this is great, but if you're not a written learner and you're more of a visual learner, we can actually do this in a graphing method. So let's plot them two graphs. So you can put x squared plus 2. No, we've done x squared plus x. Or if you want equally, you can put y equals. It doesn't matter. It does want to do it. Does it like that? So y equals x squared plus x, and just to highlight it doesn't matter, I'll put this one as just as 2x plus 2. Now if we graph these two equations, you can see that in blue it shows us the parabola, which is a quadratic, and it shows us in green the linear function. Now the great thing about this is we can actually trace the points. So if we press this, and we can drag it and do it manually. So what I was saying about the intercepts earlier is if we drag it to where the lines cross, basically when y equals 0, x equals -1, which was one of the answers we got, and if we drag it over to the other place where it crosses, when y equals 6, x equals 2, which was another one we got. And we can check this by going back to our worksheet, where it also gives us a nice little graph that's plotted. Excuse me. And there's our two solutions, x equals -1, which was one we found out, and x equals 2. So that's another thing it's great for. It also gives us a nice little copy of the graph, which we can print out. We could then put into a maths folder or anything that we've got. Another thing that it does really well is surds. For example, if we have 1/√3, now mathematicians might have already spotted the problem with this. Surds need to be what's called rationalised. That means the root can be on the top, but it can't be on the bottom, or it shouldn't be. So what normally you'd have to do is you'd have to times this by 1/√3 by √3/√3. What that does is it puts the √3 on the top and cancels out the √3 with a √3 on the bottom, which is 3. So, but if we press enter, we can cancel out all this problem, and it just gives us the output in standard form, √3/3. It also gives us the decimal output again. Another thing it's great for is differentiation, integration. I'll give you some examples here. X to the 3 plus x to the 2 plus x as an example. And now we enter that, and now we can differentiate for x. And here it gives us a notation, d by dx. If we put y equals x cubed plus x squared, the notation should change. I don't know if it will, but it should change to dy by dx. I'll check that for you. So if we put y equals x cubed plus x squared plus x, and I'll press enter, it's actually solved it, which I didn't want it to do. But anyway, yeah. If we put x cubed, sorry, plus x squared plus x, we can also integrate on x at the click of a button. So it gives us again the standard notation, x cubed plus x squared plus x with respect to x, and the output is x plus x to the power 4 over 4, x to the power 3 over 3, x squared over 2, plus a constant, which we don't know. It doesn't just do integrals, it actually does definite integrals, but I don't think that comes up on core 1, and it does a lot more. Another great feature about it is you can actually click File, Export to Word, and you can actually save it as a Word document. So if people don't have Microsoft Mathematics, you can actually export it to a Word file, and it will keep all the notation, so it won't look scruffy. Like for example, if you was going to do mass notation for x squared, you have to do that. It won't look like that. It will keep the nice x cubes and x squared. That's about it that's all you need to know really with the mathematics for core 1. I will release further videos showing you how to use the functions on here for core 2, core 3, core 4, and maybe even some further pure modules. Thanks for watching. Please check out my website. That's www.sixthform-online.co.uk. Join as a member. It's free of charge.